Chapter 6. What's the secret to getting students to think?
The first step, use students' background knowledge. The implication of this is students are ready to comprehend, but not to create knowledge. Trying to get our students to think like experts, mathematicians, scientists, and historians is not a realistic goal. However, as teachers, our goal is to provide knowledge to our students in hopes that our students begin to gain an understanding of the content being taught. Experts know what is important versus what should be ignored and can access this information with great speed and accuracy. Experts not only have understanding of their topic, but they continue to add new knowledge. This is what separates the experts from the novices. This doesn't mean that experts don't make mistakes, but when they do it with grace and they move on. At the end of the day, the goal is for our students to be able to create knowledge and not just do activities that ask our students to think about knowledge creation.
The second step is to continue to practice. On page 137, Willingham says that the only path to expertise, as far as anyone knows, is practice. I'm sure everyone's heard the old saying, practice makes perfect. And there is some truth in that, though maybe we need to change the word perfect to improvement. The implication, don't expect novices to learn by doing what experts do. In the classroom, practice is important on so many levels. It helps students work through their background knowledge of their subject, giving them a chance to attach meaning to the concept so that they can internalize the information, thus pushing the information into their long-term memory. Practice also helps hone the necessary skills in each content area that are needed to make simple tasks automatic. For example, in math, knowing the multiplication table is handy, but the only way to memorize these groups of numbers is to practice multiplication over and over, and the same goes with pronunciation in French. As an educator, we need to recognize that students cannot practice in the same way that experts work, but that our job is to give our students necessary skills, such as life lessons, in order to one day become experts. So we have our students go through labs in science class, even though they may know the outcome of the experiment, so they can hone those necessary skills of performing experiments, making a hypothesis, following directions, making calculations, reflecting, etc.
The third step is to motivate students to be creative. Implication of that is that activities that are appropriate for experts may at times be appropriate for students, but not because they will do much for the students cognitively. Assignments that demand creativity may also be motivating. However, they must match with the students' current cognitive equipment that they have, or else they won't have a great time with the assignment. At the top of Bloom's taxonomy pyramid is creating, which is a multi-tiered model of classifying thinking according to 6 cognitive levels of complexity. The levels have often been depicted as a stairway, leading to many teachers to encourage their students to climb to the higher level of thought. Students don't necessarily need to become experts in the field, but they do need to have an understanding of how the process works.
Students are not experts, and we should not treat them as such. Through utilizing their background knowledge, continuing to practice, and motivating creativity, students can one day become experts. After 10 years, that is.